Hello everyone, myself Dr. Sonam Gupta, working as a professor in the Department of Computer Science and Engineering. So today we are going to discuss a complex topic in cloud computing, that is parallel and distributed computing. So let's explore what is parallel and distributed computing and how they are being used in this cloud computing. So there are various underlying principles of parallel and cloud computing. So we all know that the parallel and distributing computing, they are powerful concept in the world of computers science that enable us to work together efficiently to solve complex problems. So both of these are used hand in hand. So if I talk about parallel computing, that means computing parallelly together so that the time is not being wasted. And if we talk about distributed computing is again same. We do not have the resources at in my end, and what I am doing is I am working on another system, and I am not aware that where that system is located, but it is being seen that I am feeling that the system on which I am working, it is having all the required hardware and the software part. So let's see this one by one. What is parallel computing? So parallel computing, it is a method where multiple processors or computers, they work together on a problem, then splitting it into smaller tasks, and then they are executed simultaneously to achieve faster results. But the thing is to be kept in mind, the tasks, they should not be dependent on each other. So the tasks are broke down into smaller parts, keeping in view that they are independent of each other. So parallel computing, it is, we can say we are having group of friends who are working on a big puzzle together. Now what will happen if a single person is solving that puzzle, then it will be solved slowly. But if everyone look at different parts of the puzzle simultaneously, then it will be solved very faster way. So another example is that when a movie, it is rendered with special effects, then multiple computers, they work together to calculate the images for each of the frame, and each computer then handle a portion of the frame, and thus this parallel processing speeds up the rendering process. So let's see this figure. There is a user is working on a parallel computing system. Now on this parallel computing system, we are having various CPU. So we are having 3 CPUs over here, CPU 1, 2 and 3, and we had divided our task into 3 tasks, task 1, 2 and 3. Now if earlier we have not divided our task into parts, then what will happen? Then only a single CPU will be working on that complete task. Now by breaking the task into multiple parts, all the CPUs are being kept busy, and the problem will also be solved at a faster pace. What are the advantages of parallel computing? We are having 5 major advantages of parallel computing: speed and performance, scalability, cost efficiency, reliability and resource utilization. So first one is the speed and performance. So it is achieving faster execution times. No doubt the speed and the performance of the system is increased at a higher rate when we are breaking the task into multiple parts. Second one is scalability. So by scalability, it is handling larger workloads and the complex problems more easily. Next is cost efficiency. Now making optimal use of the hardware resources, the cost efficiency is no doubt increased. It is also reliable because it ensures fault tolerance and redundancy for uninterrupted operations. And finally, the resource utilization, that is optimizing the use of available CPU, memory and storage resources. Along with these advantages, there are few disadvantages as well. So the disadvantages include complexity, specialized hardware, communication overhead, programming challenges and the scalability limits. So first one, it is the complexity. So the challenges in design and management, and it requires expertise in the parallel programming as well. Second is specialized hardware. So the cost associated with the specialized processors and the GPUs. communication overhead, potential latency issues in distributed parallel systems, programming challenges, so issues like race conditions, data inconsistency problems arise in it, and practical constraints to efficient scaling is also a problem in parallel computing. Now, there are various applications of parallel computing where it is used, like weather forecasting simulations, big data analytics and processing, speeding up the computer graphics rendering, like I have given the example of that movie as well, financial modeling and risk assessment, engineering simulations like structural analysis, genomic solutions, sequencing and bioinformatics, seismic data processing for oil and gas explorations, training deep learning models in AI, real-time sensor data processing in IoT, and complex optimization problem solving. So, these are the few applications of parallel computing where it can be used. Now, next is distributed computing. So, let us see what is distributed computing. So, distributed computing, it is a method where multiple computers, they are geographically separated, but they work together to solve a problem by dividing it in smaller tasks. And then what happens? Then these systems, they communicate with each other, they coordinate the efforts to achieve the desired outcome. Now we can take it like a distributed system as a team of people who are working on different locations, but the project is same and they are working no doubt through internet only. Now then they share their work and to achieve a common goal. Now let's take an example, like we are having a ride sharing app Uber. Now when we request for the ride, the server for the application, it is located in different data centers, but they work together to find the nearest driver and then they calculate the route, and this is done only because of the distributed servers. Let's see it over by the help of this figure. A user is there and a distributed computing system is there. This distributed computing system, it has various nodes. So, likewise we are having 3 nodes over here. Each of the node is having its own processor. So, they are having their own processor and their own memory. Now, what is being done? The task is divided into these 3 nodes. These 3 nodes are computing the task independently. After the work is finished, after the work is completed, these nodes will combine together and will give the single result. So, this is the basic concept behind distributed computing. Now, next is the advantages of distributed computing: reliability and fault tolerance, scalability, performance improvement, resource utilization, and geographic flexibility. So, reliability and fault tolerance, ensuring continuous services through redundancy. Scalability, facilitating handling of growing workloads by adding the resources. Performance improvement, enhancing computational speed through task distribution. Resource utilization, efficiently utilizing available computing power and storage. And geographic flexibility, facilitating collaborations across different locations. Along with this, distributed computing is having certain disadvantages as well, like complexity, security challenges, communication overhead, software complexity, and scalable limits. So, first one is the complexity. So, challenges in design and maintenance requiring specialized knowledge. This is the major complex problem. Communication overhead. So, latency issues are there when the data is being transmitted between the components. Security challenges because the data is being transmitted over the network. So, ensuring data integrity and confidentiality over network transmission. Software complexity, managing data consistency and synchronization in distributed systems. The cost, investment and maintenance expenses for networking infrastructure and specialized hardware, scalability limits, practical constraints to efficient scaling in large-scale systems. So, these are the applications of distributed computing. First one, it is the CDN. What is CDN? CDN is Content Delivery Network. Another application of distributed computing is cloud computing. This is a very well-known example for distributed computing. Third one is the distributed databases, because databases is being kept in a distributed manner. So, this is again an example of the application of distributed computing. Online video streaming, Internet of Things, IoT, most common these days. So, this is again an example of the, or we can say, application of distributed computing. Social media platforms, Facebook, Twitter, Insta, again an example of distributed computing. Blockchain technology, online collaboration tools. So, these are the few applications of distributed computing. So, till now we have discussed what is distributed computing and what is parallel computing. Now, let's see, because more or less they seems to be similar, but there are few differences between them. Let's see what are the differences between parallel computing and distributed computing. For the parallel computing, many operations are performed simultaneously. For the distributed computing, system components, they are located at different locations. Parallel computing, single computer is required and that portion is being broken up. In distributed computing, it using multiple computers. For the parallel computing, multiple processors, they perform multiple operations. For distributed computing, multiple computers perform multiple operations. So, that is same. So, parallel computing, it may have shared or distributed memory, but in distributed computing, it is having only distributed memory. In parallel computing, processors communicate with each other through bus, whereas in distributed computing, computers communicate with each other through message busing. Parallel computing, it improves the system performance, whereas distributed computing improves system scalability, fault tolerance and resource sharing capabilities. So, these are the major major differences between parallel computing and distributed computing. Next is elasticity in cloud computing. So, elasticity, it is a fundamental characteristic of cloud computing. And what it refers to? It refers to the ability of a cloud service to automatically and dynamically scale computing resources up or down based on the demand. So, as per the demand, it will increase the computing resources, and if the demand is low, then it can decrease the computing resources as well. It enables businesses and users to scale up their applications and services as required, ensuring optimal performance and cost effectiveness. So, now this is the block diagram which ensures elasticity. We are having a scale and a cloud environment. So, for this cloud environment, various things are like we are having Elastic Manager, virtualization and this infrastructure. This is scale, it will directly communicate with this Elastic Manager, the virtualization, and in turn it will communicate with this infrastructure. Now, what is Elastic Manager? The Elastic Manager, it monitors the workload and initiates the scaling. What is virtualization layer? It facilitates dynamic provisioning and deprovisioning of the resources as and when required. And infrastructure layer, it hosts physical resources to meet the scaling demands. So, these are the we can say this is a block diagram which explains the elasticity for this cloud computing, how this environment is going to work, what are the layers that are involved in it. So, there are various key aspects of elasticity. So, first one is the on-demand resource provisioning. Automatic allocation of resources such as virtual machines and storages without manual intervention. Automatic scaling. continuous monitoring of workload metrics, triggering automatic scaling during workload spikes. Whenever the workload will increase, it will automatically get triggered out. Horizontal and vertical scaling. So, it is the explanation for both the horizontal and vertical scaling strategies. Cost efficiency. So, we are having cost saving benefits through automatic resource adjustments. Improved performance and availability. It ensures optimal application performance and fault tolerance during the fluctuations. And application aware ceiling, so it provides a description of application specific scaling decisions for optimized resource allocation. So, there are various examples of this elasticity. First one is the e-commerce site experiences traffic surge during sales events. Whenever the e-commerce sites they are having their sales. So, what happened? The sales event, during sales event, the traffic is also increased over it. So, there is an issue of placing an order and all those things. Cloud provider, it automatically increases virtual machines during the high traffic. So, there the cloud computing comes into the scene. Resources, they are scaled down when the traffic returns to normal, ensuring cost efficiency and the optimal performance. So, there is an on-demand provisioning in cloud computing, and for this on-demand provisioning only, cloud computing is being used to this high scale. So, on-demand provisioning, it is a fundamental concept of cloud computing in which the users acquire and allocate computing resources such as virtual servers, storage, etc., and they are required when they are needed. Now, this provisioning model, it provides flexibility, scalability and cost efficiency by eliminating the need for upfront hardware investments and allowing resources quickly added or removed as the workload requirements get changed. So, these are the various key points of on-demand provisioning. First one, resource flexibility. So, it provides various computing resources which are available for provisioning. So, we have seen this as well. These are the key points and it includes basically a structure, resource flexibility, instant availability, cost efficiency, self-service, resource monitoring is there, security and compliances is there, use cases and scalability. So, if you are using cloud computing and for that elasticity, these are the on-demand provisioning that can be used in it. Use cases, these are the specific examples which provides different scenarios where on-demand provisioning is highly beneficial. Like for example, I am using any software, I just want one part of it to be used and rest is not of my use, and if I purchase that software, it is causing me in lakhs, but if I am using only its services, then it is costing me few bucks only. So, what is the major use that I can do? I can go for cloud computing elasticity and there I can get the data. So, self-service, it includes how the users, they can independently manage the resources without IT interventions and fostering the agility. Resource monitoring, introduction to resource monitoring tools which are provided to the cloud services. Security and compliances, so importance of adhering to security and compliance protocols during the resource provisioning. Now, why this is required? Because we all know that if we are talking about cloud computing, that means the data is being traveled over the network. Whenever the data is being traveled over the network, so there is a high chance that the data will be misinterpreted. The data can be hacked. Security is always a challenge in these things. So, for that, security and compliances are required to be done. Now, examples of on-demand provisioning, we can say the startups when they develop a web app with a fluctuating traffic. During peak times, more virtual machines are required for optimal performances. With on-demand provisioning in the cloud, extra virtual machines are auto-deployed during the peak hours. Off-peak hours see resource reduction for the cost saving. So, there we can reduce the resources as well. So this is according to our demand. If the demand is high, then the resources will be increased, and if the demand is less, then we can decrease the resources as well. Off-peak hours see resource reduction for the cost savings, and on-demand provisioning ensures efficient resource scaling for a seamless user experience and the cost management. So, for this, on-demand provisioning plays an important role. So, here we have seen the differences between the parallel and distributed computing, how they are being used, in cloud computing, how distributed computing, or we can say the distributed systems are being used in cloud computing, what is the role of elasticity, and what is the role of on-demand provisioning. Thank you.